Neon, which is a noble gas that is solid at 0 Kelvin, which is minus 273 Celsius. Neon's atomic number is 10, and it is located in the p block, group 18, and its period in the periodic table is 2. Neon is a colorless, odorless, inert monatomic gas under standard conditions, with about two-thirds of the density of air, which means it can't move and it is made of one atom. Neon is obtained from the air by fractional distillation. A container of air is changed into liquid state. As the liquid starts forming, different elements change back to gas from a form at different temperatures. Neon is the air portion that changes back to gas at minus 248, 5.92 Celsius, and then it is collected. So, there are 2 electrons in the 1s orbital and 2 in the 2s orbital, and 6 goes in the 2p orbital. There are 10 electrons altogether because the amount of electrons in an element is equal to the number, and also the number of protons is the same. Neon has 3 main isotopes, which are Ne22, N21, and Ne20. The most abundant isotope of neon is Ne20, with a natural abundance atom percentage of 90.48, and neon is also the 5th most abundant element in the universe. Neon costs $2.28 per gram. In the 1970s, neon cost was $200 per gram. But since then, the price of neon has been dropping, with only a rise in 2000, when neon rose back to $128 per gram. The reason for the drop in the price of neon is because in 2015, there are other things used instead of neon. Neon was mostly used for lighting, but since it has a low energy output for its input power, expensive for use as signs and displays, and also it requires a large surface area to be used for general lighting. Other light sources have been used instead, such as LED and laser. The graph shows that there was a huge rise in the price of neon in the 1970s, after the price dropped and did not have any major change, with the price ranging between $5 and $100 per gram, and there was a slight rise in 2000 when the price reached above $120, and then the price dropped to an all-time low of $2.28 per gram. The most common use of neon is lighting signs. Neon lighting consists of brightly glowing electrified glass tubes or bulbs that contain rarefied neon. Neon tube lights are sealed glass tubes with a metal electrode at each end, filled with the gas at low pressure. Light emits from the tube when several thousand volts are applied to it, which ionizes the gas, making it emit colored light, orange light only. Neon lights can last up to 20 years, which solves the problem of changing the lights more frequently, making it available for shops to put up neon signs above their shops without worrying about needing to change the lighting for the next 20 years. Neon lighting was discovered by French engineer Georges Claude in 1902 to show the public. He created the lights by using Henry Geisler's idea of applying electricity to a tube filled with gas at low temperatures. Then Georges started experimenting with a newly discovered element called neon, and he applied electricity to a tube filled with neon at low pressure. The neon light business rose increasingly as people all around the world were buying it after Georges sold licenses to investors. By the time Georges died at age 90 in 1960, Las Vegas and other major cities were covered in neon lighting. Before neon signs, wood was painted on. The reason why neon is the element used in the product is because neon has a nice bright orange glowing color, and neon can last for about 20 years before you need to change it. Cryogenics is the study of and production of materials at very low temperatures. Ed Busch invented cryogenic refrigeration in 1966 with a background in the heat treating industry. Cryogenic refrigeration is done by cooling gases such as hydrogen and helium to about minus 180 Celsius, which is 93.15 Kelvin, transferring the gases into liquid form in order to cool materials to temperatures that cannot naturally occur on Earth, so that the material's durability becomes about 200% to 400% better. The reason neon is better than hydrogen or helium is because liquid neon's refrigeration capacity per unit volume is over 40 times of liquid helium, or liquid hydrogens. Ne22 is the isotope found in helium neon laser application. The ring lasers found in commercial, space, and military navigation and control systems are one of the critical applications of Ne22. In an initial guidance system, the ring laser gyros, which is RLG, can be used as the stable element, which is a navigation aid that uses a computer, rotation sensors, and motion sensors to continuously calculate via dead reckoning the position, or an orientation and velocity of a moving object without the need for external references. Comparing to a spinning gyro, the advantage of using an RLG is that there are no moving parts, so there is no friction, which means there will be no inherent drift terms. It can be used in aircrafts because it is lightweight, compact, and virtually indestructible. This is the laser. This is the LRG. Thank you.